So in this video we're going to do a trigonometric substitution using an example involving a rational exponent. So here we have the integral of negative 3x over x squared plus 3 to the 3 halves power. So we have a rational exponent here. And what we're wanting to recognize is that we can rewrite this as x squared plus 3 under the square root or under a radical. And then we're cubing that. So the square root of x squared plus 3, quantity cubed, is the same as x squared plus 3 to the 3 halves power. And we want to recognize that we have the sum of squares under here, because 3 can be rewritten as the square root of 3 squared. So we have a sum of squares. So we're being given, in a Pythagorean theorem context, we're being given the lengths square root of 3 and x of the legs of a right triangle. So if this is my angle theta, then the hypotenuse is going to have length x squared plus 3 because of the reasons discussed in the previous two videos. So once I do this, I see that I quickly get a nice clean tangent relationship out of this. Tangent of theta equals x over the square root of 3, but we can multiply both sides by root 3. So square root of 3 times the tangent of theta is x. So now we have something that we can substitute in for the x. We also need to know what dx is, and this is going to be the cleanest relationship from which we can come up with dx. So we'll want to take the derivative with respect to x of both sides. So we'll get square root of 3. The derivative of tangent is secant squared of theta. The chain rule says that we need to take the derivative of the inside function, so we need to take d theta dx. So that's using implicit differentiation, and then we take the derivative of the right hand side. The derivative of x is 1, multiply both sides by dx. And now we know that we can replace dx with root 3 secant squared of theta d theta. Finally, we need to come up with something to do with this x squared plus 3 to the 3 halves power in the denominator. So what we want to notice is that the cosine of theta right here is just the side adjacent over the hypotenuse, and the hypotenuse is the square root of x squared plus 3. And then to get the 3 halves power in the denominator, right now I have the half power, I'm going to need to cube both sides. So cosine cubed of theta means I need to cube both sides of the relationship. So we get cosine cubed of theta is the same as the square root of 3 cubed is going to be root 3 times root 3, which is 3, times another square root of 3. So we get 3 square root of 3 out of that. And in the denominator, we're going to have the x squared plus 3. This is to the half power times 3 is the 3 halves power, which is exactly what we have in the denominator right here. If I multiply both sides by 1 over the square root of 3, now I have a 3 in the numerator position that like I do here. And then if I multiply both sides by negative 1, I see that I have negative 3 over x squared plus 3 to the 3 halves. So I can replace the negative 3 over this with negative 1 over the square root of 3 times the cosine cubed of theta. So now it looks like we have all 3 pieces that we need. So we are starting with this integral. So I rewrite the integral to the 3 halves dx. We can step into that integral and replace the negative 3 over x squared plus 3 to the 3 halves with the negative. I'm going to give myself a little bit of space here. I can replace it with the negative 1 over the square root of 3, which is a constant and can be factored out front. The function cosine cubed of theta goes on the inside. I can replace the x right here with the square root of 3. So the square root of 3 can factor out front because it's a constant. The x gets replaced with root 3 tan theta, so we put a tan theta in here. And finally the dx can be replaced with the square root of 3, which is a constant and can be factored out front. And then secant squared of theta d theta. So there's all of the substitutions. And then we want to recognize that the secant is the reciprocal of the cosine. So cosine squared times secant squared would be 1. So the cosine squared will cancel out of this, leaving us with just a cosine cubed. Remember, secant squared is the same as 1 over the cosine squared. So 1 over the cosine squared would mean that we're dividing that by the cosine squared if we have a secant term here. And so that's going to simplify. So we get negative square root of 3 sitting out there. Cosine cubed divided by cosine squared is the cosine of theta times the tangent of theta, d theta. And because the tangent is sine over cosine, because the tangent is sine over cosine, by definition from trigonometry, the cosines will cancel. So with that tangent sitting there, what we want to recognize is that the cosine of theta times the tangent of theta is just equal to the sine of theta d theta. And now we just need to integrate the sine, but the antiderivative of sine is minus the cosine. So the antiderivative of this, because the minus is sitting here, is just going to be the square root of 3 times the cosine of theta. You can check your work. Derivative of cosine theta is minus sine theta, so we will get the minus back that we need, plus our constant of integration. And so now we know what the integral is in terms of trigonometric world. We need to convert back into rectangular world. So the cosine of theta we can see from here is going to be adjacent. So we get square root of 3 times the square root of 3 is adjacent over hypotenuse. So square root of 3 over x squared plus 3, plus that constant of integration, root 3 times root 3 will just give us a nice 3 over the square root of x squared plus 3 plus a constant of integration.